Hey, welcome to Genie YouTube channel. So in this video, we are going to run through unsupervised learning, machine learning model. So in unsupervised machine learning model, algorithm is given a data set without explicit instructions and without labels being mentioned, or we can't recognize the labels from the given data set. So in supervised learning model, we discussed about how input and output are related, or how the relationship between the input and output variables are established. And we also saw how features in the data sets were explicitly called out, and how labels were predefined, and how machine learning model use features to predict the outcome, which is nothing but again a label. And here in the unsupervised learning, there are no input output pairs. So this kind of learning is used when there is input data X and no corresponding Y output label. So in unsupervised learning, objective is to find hidden patterns, data structures, and hidden correlations, similarities, dissimilarities within the data set. So it's just like rules of games. Just by watching the game from time to time, we'll understand what's going on with the game and what are the rules of the game. It's like the way babies learn without getting taught, right? So if, for example, if a baby for the first time, it may not recognize that something hot is going to hurt his hands, right? Maybe a cup of tea in its vicinity, and the baby might get tempted to go and grab it or touch it or play with it, right? So moment it goes near by the cup of tea, it sees the color of the tea, and it see uh, the vapor coming out of the teacup, and it might make the baby curious to go and touch it. So the moment it touches it, it is going to take his fingers off the teacup, right? And it knows it has got his hands hurt. Now, as soon as this experience plays out for the baby's sensory perception puts information into its neural work. Anything that's hot or anything of this color with vapor coming out will hurt his fingers. So this experience gets set out in its neural network. So next time when it see such an object or similar object or a cup of tea itself with the same color with vapor coming out, it instinctively keep itself away from himself or herself away from that cup of tea, because it knows instinctively out of its previous experience which has got registered in its mind that it's going to hurt his fingers. So that's how this is a layman example to talk about unsupervised learning, or how unsupervised learning works. And there are some prominent unsupervised learning models, such as clustering, association rule mining, anomaly detection, auto recommender system, dimensionality detection, and data generation. There are many kind of algorithms, and all the kind of algorithms can be leveraged for all the kind of machine learning models, depending upon the objective or the type of application or the context at which the data set is getting fed and used for. So let's go by these prominent learning models, essentially types of algorithms one by one. in unsupervised learning model. So the first one is clustering. Clustering gets applied wherever data set needs to be explored and analyzed for the similarity of the data elements, or to identify the pattern of the types of data elements in a given data set. So the motive of clustering is to find the similarity within a cluster on the difference between two clusters. And when I say cluster, you might think of the classification learning model in the supervised machine learning type, right? So there is a difference between classification versus clustering, but still people might tend to get confused, or they mix and match classification versus clustering. So in supervised learning, the machine learning model clearly knows the classes, different types of classes of data elements in the data set, and it's already fed with labels. So the moment you fed labeled data, based upon its learning model, the AI system can clearly call out or can classify the data element that was the unlabeled data element that was fed to its machine learning model. Whereas in clustering, it's all about dealing with unlabeled data. So the unsupervised learning model will look for similar patterns in the given data set. Based on the similarities of the data elements within the data set, it forms groups of data elements, otherwise called as clusters. Now, if we want to talk about clustering further with a relevant example, we can talk about customer segmentation, right? So, the big e-commerce, for that matter, any e-commerce organization would try to group their customer base based on their shared characteristics and behaviors to adjust or to tailor their marketing strategies and product offerings. They do this exercise time to time, right? This involves data collection, data pre-processing, feature selection, choosing right algorithm, which is the basis of the machine learning model, and determining a number of data groups, or otherwise called as clusters, and then model training, and then interpretation of the outcome of that machine learning model. And what do you make out of those interpretations, or how you adjust your business strategies based on the outcome, right? So let's see these aspects one by one, right? So unsupervised learning model starts off with data collection of the customers, variety of customers, which might include demographics of the customer, background of the customer, their purchase history, and the number of hits they make online for a particular product, and the time they take to review each and every product, and also to look for whether the customer has dropped a review a rating or not. And next comes the data pre-processing, where the collected data will be sanitized, and any missing data values will be annotated wherever it's relevant. And a rule has been set for this data. Next comes the feature selection out of the given data set. Feature selection in this case, which is customer segmentation, example also would be defining average purchase amount of the customers, could be one of the features, or frequency of their website visits can be taken as a feature. So likewise, we can define many feature that determines. It depends upon the volume of data we collect from variety of perspectives. Next is choosing algorithm. Right? In typically for clustering or for grouping, there are a bunch of algorithms like k-means, hierarchical clustering, db-scan, and Gaussian mixture models. And here, the most prominent algorithm that gets applied prominently in the clustering learning model is k-means, and it's very much suits to do this exercise of customer segmentation. And then next step would be determining number of clusters. Now, to arrive at number of clusters, a few techniques like elbow method or sellout score will be applied to find the optimal number of clusters. And then comes the model training, where we will apply the chosen clustering algorithm to the pre-processed data. And then the neural network for this learning type will get trained by the algorithm. And how it get trained? By using the data in the data elements in the data set. So algorithms trains the neural network through the data available in the data set. And then comes the interpretation part. So once this machine learning model gets deployed, it starts putting out its analytic outcomes, wherein we interpret the clusters and understand each cluster. In this case, it's essentially each segment of the customers versus respective behaviors for those clusters, meaning behavior of customers or the customer patterns. And then we will assign label to those clusters. And based upon this inference, number of clusters, interpreting the clusters, understanding their customer behavior pattern, we will or that e-commerce agency will develop appropriate level of marketing and business strategies tailored to each customer segment. Now, next comes the association rule mining part. This is also one of the prominent learning type that gets applied out of unsupervised learning model. So, while clustering techniques calculate clusters based on similarities, association rule mining will look for associations based on co-occurrences, right? It identifies interesting relationships or correlations among a set of items in large data sets. An easy example would be if we observe in a supermarket, say for example, if you go by close by the section where they have placed racked up breads, you might also see in the next rack or in the adjacent rack, you'll be finding butter spread and probably the knives that spreads butter out in the bread, right? So when a customer purchases bread, there's a certain amount of probability that the same customer would buy butter as well, and then subsequently knife if he or she doesn't have knife to spread that butter. So there's a logical relationship on this purchases that most probably prone to happen. So if we look at this retail and market basket analysis example, that involves a data collection where transaction data will be collected, which represents customer purchases over a specific period of time. And data will be collected in such a fashion that each transaction will be seen as a set of items that a customer bought during a single shopping trip. and then gets the association rule mining applied. And there are some prominent algorithms that plays out the logic of association rule mining, or a priori, or FP growth. So either of these algorithms will get applied to the transactions data, and this algorithm might discover some rules, like if a customer buys a product A, they're likely to buy product B as well. So it establishes correlations, or it will deduce co-occurrences when a customer purchase record is sent as data set. And then the machine learning language will do the rule evaluation part, wherein it will evaluate the discovered rules based on metrics like support level, confidence level, and it also analyze the proportion of transactions that contain the items in that for the particular rule. And then the confidence level comes into play, which is the probability that a transaction containing product A will also contain product B. And there is something called lift parameter, which talks about the ratio of the observed support level to the expected support level. And then comes the insights and action part. So as we evaluate the rule outcomes, the machine learning model will identify high confidence and high lift rules that indicate strong associations between products. For example, if the rules suggest that customers who buy diapers are also highly like to buy baby formula. So, knowing this, the store can strategically place these items close to each other to run joint promotions. So, this is about association rule mining.